everyone. If you're watching this video, then it is because you are trying to study for our test. So, on Wednesday, we are going to be taking our Unit 1 Chemical Reactions test. Okay, so really quickly, I'm going to review just the 6 things that you should be keeping an eye out for your test and things that you should be studying for. So the first thing that you want to be studying is our significant figures. Okay, so with significant figures, there are several rules that you should be following by, rules to live with. So the first rule is that all non-zeros are significant. This means that they contribute towards the accuracy. So, for example, if we have the number 4.375, all 4 of those digits are significant. So we have 4 sig fig because all 4 numbers are non-zero. The second rule is that leading zeros never count or are never significant. So a leading zero is something similar to this. So if I have a 0.0437, these 2 zeros at the front are leading the way, so they do not count. So this number would only have 3 significant figures. Or if we have the number 0.00002, all of those zeros are at the front. They're leading, and so we only have 1 significant figure. The 2 is significant because it's not a 0. Rule number 3 is that captive zeros are always significant. And so this means if a captive zero is one that's trapped in the middle. So if I have the number 407, that 0 is in between 2 non-zero numbers. So this would have 3 significant figures. If I had the number 8,004 or 84,008, right? Both of these are captive because it's in between the 4 and the 8. So we'd have 5 significant figures. If I had the number 0.005704, I would have 4 significant figures because these zeros in the front are leading, so they do not count. And we have 5704. 3 non-zero numbers plus 1 captive zero. And then rule number 4, okay, says that trailing zeros, or zeros that come at the end, are significant only in a certain situation, only if there is a decimal. Okay, so it's only if there is a decimal. For example, if I have the number 4,000 like this, there's no decimal, so I only have 1 significant figure. If I have the number 4,000 with a decimal, now all 4 of these numbers are significant. Okay, so what if I have the number 0.004040? Okay, well, we know that the 4 are significant because they're not a 0. These 3 zeros at the front are not significant because they're leading zeros. This 0 is significant because it is a captive 0, and this 0 is significant because it's a trailing 0 at the end, and there is a decimal in this problem. So this would be a total of 4 significant figures. The 5th rule applies to scientific notation. So only numbers in the coefficient of scientific notation count. Now, one thing to keep in mind is scientific notation always has a decimal, so zeros in there are always going to count. And you can't have a number less than 1, so you never have leading zeros. So for example, let's say I have the number 5.230 times 10 to the 14th. Okay, these numbers are in the coefficient. It's anything before the times 10 part. Okay, the times 10 to the 14 would just tell me that I would move my decimal 14 places to the right. So this number would have 4 significant figures. If I have 2.7 times 10 to the negative 8, again, my coefficient is the numbers before the x, so that would be 2 significant figures. Okay, so these are the main rules of like how do you know if the number is significant, and these rules, okay, these are the rules that tell us how to round. Okay, so when we're dealing with rounding, which is included under these significant figures rules, we need to look at what type of operation we're doing. So we could either add or subtract. Okay, that's one of them. Or we could either be multiplying or dividing. Okay, so if we're looking to add or subtract, you want to round to the lowest number of decimal places. So let's take a look at an example problem. You should have a calculator in front of you so that you can test this for yourself. So if I have the numbers 30.974 plus 27.2 plus let's say 15.78, and I want to know what that is equal to. Well, I would put it in my calculator because I'm bad at mental math and I don't trust myself to do it without making mistakes. But when I put this in my calculator gives me the number 73.958. So the question is this number rounded correctly? So because I'm adding, I'm going to round to the lowest number of decimal places. So in the first number, I have 3 numbers after my decimal. In my second number, I have 2 numbers after the decimal. And in my third number, I have 1 number after the decimal in this second problem, and 2 numbers after the decimal in this third one. So that means the lowest number of decimal places is 1. So only 1 decimal place there. So I want to round my answer to only have 1 decimal place. So that's that first 9. So what we do is we look to the 5 behind it. Does that make this 9 round up or stay the same? We know that the rule is if it's 5 or higher, we round up. 4 or lower, it stays the same. So this number will round up to 74.0 because 9 rounds up to a 10, so you put the 0 here and add the 1. That's kind of how I remember, because that can be a little tricky sometimes. But you cannot forget to write the 0.0 because we need that decimal place. So this would be my correctly rounded number. If we are multiplying or dividing, instead of rounding to the lowest number of decimal places, we round to the lowest number of significant figures, okay, or sig figs. So let's say we're doing the problem 45.0 times 23 divided by 0.002. Okay, what we would do is we would do that in our calculator because even if you are good at mental math, I doubt you're doing this type of math in your head. So 45.0 times 23 divided by 0.002 would give you the answer 517,500. Okay, so when we look at our answer choices, these two are significant, and so is this one because it's a trailing zero and there's a decimal, so I have 3 sig figs there. I have 2 significant figures here, and I only have 1 significant figure there. We want the lowest number of sig figs, so that would be 1 significant figure. So I need to round this to only have 1 significant figure. So we keep the 5, the 1 makes the 5 stay the same, and then I add zeros until the magnitude of it stays the same. So this is still 500,000, and it's reasonable to think that under certain circumstances we might round 517,000 to 500,000. But if I did not keep those zeros, then I would not have a correctly rounded answer. And if I were to put a decimal at the end, I would still not have a correctly rounded answer, because now that would make those trailing zeros significant, but we want to keep them out of the way. Now, if we had needed to keep one of these zeros as significant, one trick that is seen sometimes is that you put a bar over it, and that would mean that both the 5 and this first zero are significant, but the rest are not. That kind of trick will not be shown on your test, but sometimes they would, if you needed 2 significant figures, they would instead put this number in scientific notation. So 1, 2, 3, 4, 5. So it'd be 5.0 times 10 to the 5. But again, this would have 2 sig figs, and we only want 1, so we're going to leave it as it is written. So this is part 1 of your test review, going over significant figures. So hopefully that was helpful for you, and go to part 2 next.